Hello once again. Let's continue with our topic on Karnaugh mapping. We'll try to simplify Boolean expressions with 4, 5, and more variables or literals. Let's go back into our general equation. 2 raised to n is equal to n, where the lowercase n indicates the number of literals, the uppercase n indicates the number of combinations or cells that we need in a map. We are going to use variable map. We'll be having a K-map with 16 cells. As an example, let's try to simplify the function ABCD is equal to the summation of 0, 4, 5, 7, 10, and 15 together with its don't care conditions equal to the summation of 2, 6, and 8. Let's try to put this in a map. So this would be our 4-variable map. It now consists of 16 cells. Take note again that we are using gray code as to the designation of the different cells that we have in our map. For the first cell, the value for A, B, C, D will be 0, 0, 0, 0. So that's why it is equivalent to 0. The next cell will be 0, 0, 0, 1. That is 1. Take note, however, that 1, 1 and 1, 0 are interchanged as to their location because what we are using is a gray code. So same as the values of AB, wherein instead of 1, 0 here, it becomes 1, 1, and next will to that is equivalent to 1, 0. That's why from 7, instead of having it here, 8, we have 8 here. 1, 0, 0, 0 is definitely equal to 8. So let's try now to put our function equivalent to the summation of 0, 4, 5, 7, 10, and 15 into our map. Here, 0, 4, 5, 7, 10, and 15. And the don't cares will be 2, 6, and 8. In using our map, our goal is again to simplify the equation. In simplifying our equation, follow this general rule. Using these rules, what are those groups that we can have? Can we have this group? If we group these two together, that would be alright using 2 raised to n. However, we know that we can wrap them around. Why not use this? Don't care together with this. So that will be increasing the number of primes that we can have in a group. So let's try to do that. So this 2, this 1 can also be grouped together. We can group these 2 together. However, we did not maximize the number of prime in a group. Why? Simply because we can expand it using our 2 raised to n and number 4, that is, we can overlap them. Let's try to group these 4 together. What else can we group? Obviously, we can group these 2 together. Are there any other that we can group with these 2? So since there is none, then we can have them as one group. Then, we try to consider this. Where can we group this? We can wrap it around here. So the 2 can be grouped together. So if we are going to do that, did we use already the largest power of 2? It's 2 raised to n. The number of prime in a group is 2. If we try to consider these 2, we can wrap around them with this other 2 prime. So in doing so, we will be increasing the number of prime in our group. That becomes 4. So let's group them together. So actually, with this, you can observe that we can wrap around the 4 corners because there will only be one literal that will be changing as to this, that is only A, and with respect to this, that will only be C. So how many groups? Okay, we try to use, we have group adjacent primes, we have used the largest power, we have used number 4, they overlap, and we use wrap around also. Do you think the number of groups that we have is already good? Try to observe. Is there a problem? There is. What's that? That there is an excess group as to what we did. Observe again the primes that we have. This one. And with this one, we need the other 3. As to this prime, this one needed the others. This one also needed this. How about this? We try to observe it with the two groups. We have already used these 2 and this 2, whereas this group uses already this prime and this prime. Meaning to say that this blue group is an excess. Okay, because we have already used this prime, meaning which makes the blue group a redundant group. Let's try to remove the blue group. As we can see now, all the primes have already been utilized. So there is no need for the blue group in order for us to simplify the equation. It is therefore a redundant group. So how many groups that we have? We have 1, 2, and 3. So there will be only 3 groups. Let's try now to simplify the equation. So for this group, what did not change in value? Looking into C and D, as to C, 0, 0 became 1. As to D, 0 became 1. So therefore, CD is eliminated. AB remains. So therefore, it is equivalent to A prime B. This group, looking at the value of AB, A change in value where B remains, so that is equal to B1, we have B, and that with the others that will not change. Okay, so looking up here, it's only CD. So since it's only CD, C and D did not change in value, and that with B, so that becomes B, C, D. How about this group? Looking into this part as to AB, we have A change in value where B remains, so that we have B prime. And here we have C change in value, we have D remains, that is 0, so therefore that is equivalent to D prime. So we have therefore the value of this group to be B prime, D prime. Then the resulting answer for each group will now be added together to get the simplified equation for our function together with its don't care. That becomes A prime B plus B prime D prime plus BC. Let's try 5 variable map. That's now 5 variable map. We'll be needing 32 cells. With this function, the number of primes already will be 32 possible combinations. If we are going to do Boolean algebra with this, then it will be a very long and tedious process. That's the advantage of using a K-map. So we have 32 cells. First 16, okay, we have the value for that is equal to, for this A, B, C, D, E, wherein A will be equal to 0. For the other cell, A will be equal to 1. A is equal to 0, then this cell will be equal to 0, 0, 0, 0, 0, 0. This one will be 0, 0, 0, 0, 1, that is 1. Until such time we reach 15, that is now 0, 1, 1, 1, 1, as we know is equivalent. This will become 16, because A will already be equivalent to 1. So 1, 0, 0, 0, 0, that is equivalent to 16, up to 31. Now put our primes into our map together with its don't care. So 0, we have 2, 4, 5, 6, 8, 9, 15. Then we have 16, 20, 21, 23, then 30 and 31. How about our don't care? We have 7, 13, 18, 22, and 24. Let's try now to find the different groups. Again, we have this together with this. Okay, can we have this one together with this? That is equivalent to 3. 2 raised to n cannot be equal to 3, so it cannot be. So we have this group together with this. Let's try that. Then we have, again, this. How about this one? If we are going to group it with this one only, we have another don't care here. So why not use these two don't cares so that we will increase the number of prime in our group. Then obviously, there are only 2, so let's group them together. Also with this 2, okay, there are 2 don't care here, so we group them together. And again with this, how about this 2? Group them together, the 2 of them only, or we can group it here to increase the number of prime in our group. Okay. How about this don't care? Since it's a don't care, using it and there is no adjacent prime that we can group with it that is still unused, then it's unnecessary. So how many groups are there? 1, 2, 3, 4, 5, 6, and 7. Is your answer 7? So let's try to analyze. We use We group adjacent prime, group of there are overlapping groups, and we use also wrap around. However, it says that we did not use the largest possible number of primes in a group, and therefore we don't have the least number of group. Why is that so? If we try to look at this group, the brown one and that of the yellow one, they occupy the same cells. Since they occupy the same cells, we can group them together, thus eliminating A, because A will change in value from 0 to 1. As if saying, we take this map, put it on top of the other, and if we can see that there are groups that exactly on top of the other, then we can group them together. So as an example, this group is exactly the same with this yellow group. So they can be grouped together. So it's with the blue and the pink group. They are exactly the same. It is not, however, with this green group and this black group. If we try to look at it, okay, and if we try to put this entire map on this, the tendency is they will not be located on the same location. Okay. As we can see, the black one should be on this part. Okay. So they are not located on the same location. So since these two are not co-located, and also this one has no other group that we can group with, then they remain the same. So let's try to change this group and this group. Therefore, this one will now be grouped together, belonging to a single group, eliminating therefore one group. This blue and the yellow a while ago will now belong together, so that will become the same group. Instead of how many groups a while ago? 1, 2, 3, 4, 5, 6, and 7. We have actually only 5 groups. So what's now the value of the groups, resulting value of the groups that we have? So for this brown group, looking into A is 0 here and here is 1, so therefore A is already eliminated. So the value for B and C here is the same as the value for B and C here, so therefore we have only the remaining value is equivalent to B, so that is 0, so that becomes B prime. Ended with here, we look at here, what remains is only E, and that is 0, same with this, so that becomes E prime. How about the blue one? A prime becomes A. Here, BC, the same as 0, 0. So therefore, it becomes 0 and 1, B prime, C. Here, we look at it, it occupies from 0, 0 to 1, 0. Therefore, both the values of D and E are eliminated. So it will only be prime, C. How about the green one? So since the green one belongs only to A prime and it cannot be seen on A, so A prime will remain. Then we have here C and here is E. This one, the yellow group, again is equivalent to A prime. Then we have B, C prime, and here will be D prime. If we try to observe this one, the greater the number of primes in a group, the less is the remaining literals. So here we have 8. There are only 2 literals retained. Here we have only 4 and there are only 3 retained. Here there are only 2 and it becomes 4. So that's the advantage. That is why we try to group it the largest possible group that we can have to get the simplest value. There is only one that remains that is equivalent to our black group. It is contained only on A, so we have A. Then we have C, and we have D. So that becomes ACD. All the values will be ORed together to get our simplified equation. It becomes B prime E prime plus B prime C plus A prime CE plus A prime B C prime B prime, then we have ACB. How about if we have 6 variable map? In 6 variable maps, observing our figure, would be having a 2 variable map equivalent to our pink one, and inside it is a 4 variable map. First cell will be 0, 0, which will be equivalent to 0. The next one will be 0, 1, will be equivalent to 1. Then 1 and 0, this will be equivalent to 2. Then 1, A is 1 and B is equal to 1. So therefore, this is 1, 1. So this will be 3. For this first cell, that is A prime, B prime, then we have C, D, E, F is also 0, 0, 0. So therefore, this is 0. Then we will be ending with 15 because that will be A is 0, B is also 0. Therefore, the values for this cell will be 1, 1, 1, 1 or 0, 0, 1, 1, 1, 1 is equivalent to 15. This next cell will already be 16. Why? Because A will be equal to 0, but B this time is already equal to 1. So, since B is 1, so then we have 1, 0, 0, 0, 0 is equal to 16, ending with 31. This cell will start with 32 because this time A is already equal to 1. So, 1, then B is 0. So, 1, 0, 0, 0, 0 is 32. And till such time we reach 63, which is already equal to A is 1, B is 1, then C, D, E, F will also be 1, 1. So that becomes 63. All the values of for this cell is equal to 1. So let's say that we have these primes. We have prime at 7, 39, 17, and 55. If we are to consider only this map, since there is no other prime near to it, then we group it as 1. So is this one, so is this one, and this one. However, since we can see that as if this cell, okay, is inside A prime, B prime, and this cell is inside A, B prime, we can actually group these two together as if they are adjacent to each other as a cell, and these two also can be grouped together. So we can group these two, thus eliminating what? The value for A, because A here will be equivalent to A prime. A here is equivalent to 1. B prime, however, remains. So as if what we are trying to use is the 2 variable map, but they belong on not only on 2 variable map, but actually in a 6 variable map. So we can group these two together using adjacent and using also overlap. So these two can be grouped together. Definitely, we cannot group these 3 together because that is already a diagonal. So since this one is a single, we group as a single prime. So please do remember our rules that we use in K-mapping, and it can be used no matter how big the map is. If we try to use 7 variables, then 2 raised to 7 will already be 1 to 8. We will be using 8 4 variable maps. I leave that to you as an exercise. Try to do problems using 7 variables. If you want, go to 8. That will be already a very complicated map. I hope you pick up more knowledge about K-map as to this lesson. In our next video, I'll be dealing with the designs of combinational circuits. Thank you for listening. Enjoy your learning.